Okay, so in this last video, I'm going to show analysis that goes through how we do glare and how we analyze glare. Now, this is very similar to the last one of how we did renderings. In fact, it's same geometry and everything. I've added a couple little bits and pieces to this though, just so we can take a look how the glare runs. I've also just put in, just for our reference, the geometry of how the sun is moving throughout the sky in our 3D space in Rhino. Now, one thing I've added in this file that I didn't show you guys in the previous one is you can save camera views. So this is very important as you're creating these different images, because whatever whatever viewport you have active is what it's using for the Radiance camera setup. So in this case, you'll notice here it says the camera is glare 1. Now what happens is if I go to set view and click on glare 1, it's actually going to set it back to what I have saved at that view. Okay, and so you can save different views, different perspective views here, even plan views or really any type of view. So if I wanted to move this around to, let's say, this position and save it as another view, I can go to set view, named views, and then click save as and name it something. And then I'm not going to do that for this, but then you can simply go back to set view and it'll be listed in that file. Now this is all saved in your Rhino file. These views have really nothing to do with the Grasshopper, but what it does is it allows you, as you're creating a series of renderings, if you slightly move your view or change the perspective or something like that, you can make sure that you always go back to that previous view. So it's kind of a handy feature when you're creating a series of images that you want to all have the same exact viewpoint. So this file that I've set up for glare, this is very, very similar to the previous one with the rendering and the false color. You have your materials and your geometry. You run the analyses, but the analysis recipe is a little bit different, okay? And really the only major change though is this camera type. And so what you'll notice here is by default it's set to 0, but I've inputted a number 1 into there. And if I highlight over camera type, you'll see number 1 is fisheye. So fisheye is critical to get a glare analysis properly, because glare analysis takes into account your entire view, like your whole view cone. So what we can do here is we really have that's really the only major change. The other thing that I've just kind of added in here is that legend, which is, tells us kind of where our sun is moving throughout the whole day and time of year. This is just kind of handy for seeing, what the hour is and what day, like where that sun is at that point. It's just a handy visual to take a look at, as you're creating these things. It really doesn't have anything to do with the actual images. I just like to have it in there for a reference. Okay. So, like before, I've already run this analysis. To run it, you guys are going to set this thing to true, the big thing that says set to true. But again, I've already run it. I've changed the name to Glare View 1 just so it saves it as a different type of image. And again, you'll see there's nothing being output as an image path because this isn't run right now. I've previously run this. I have it in some file here that's just in a panel. And what I'm doing is then putting it into this HDR to GIF, okay, which is showing us what that image looks like. So it's a rendering with a fisheye lens, basically. So it's giving you a 180-degree view So that's kind of handy, but what it's also doing is a couple other things. It's creating, um, it, when you run this, it does this DGP analysis. Now this is glare probability, okay? Now we'll go over this a little bit more in depth, what the glare probability index is in class next week, but for right now, you basically, that number gives you an idea of how much glare you're probably going to have in a particular view. And glare always has to do with your viewpoint. So you can have glare looking in one direction in a room, turn around, and then you don't have glare. So it really all has to do with this view and where we're looking. Okay. The other part of the output is um, this daylight glare probability honeybee glare analysis, which uses that DGP, and then it outputs the number here. Now, the reason this is different right now than what you have in the image is just because I'm running it from that file path. So it should work fine once you guys run it live on the real image. But basically, this just creates that border with that daylight glare probability on it. Okay, so hopefully that'll get you started on your glare analysis, and we can start taking a look at those next week in class.